Let's look at completing this problem using Desmos. And I want to start by, here on my Desmos tab, adding a table so that I can input the values that are given in the problem. All right, and you can see I've already entered those values there. Next, we were asked to use the model y equals ab raised to the x. And the only difference I need to account for here for this to be well, actually there's two differences I need to do to make this into a model. First of all, I want to use subscripts of ones. And if you come right behind the variable and just type the number 1, it will automatically do that for you. And next, the other thing I want to do, instead of the equal sign here, I need the tilde symbol, which is shift, and it's a key beside the 1 key on your keypad, usually up in the top left corner. It looks like just one little squiggle sign. One more thing you'll need to do at this point is click the box beside log mode. You can read more about what that does if you click on this question mark here, but the main thing you probably need to know though at this point is that the TI calculator uses log mode automatically, a logarithmic transformation. Desmos does not, but my math lab is expecting you to. So long story short, click log mode. This gives you the parameters A and B. You'll come back to the screen, type those in that form, A times B raised to the X. And you can see I've typed that in here. In the next part, you're asked to just express this same model in a slightly different form. And to begin with, I see n sub 0 here as an initial value. That's going to be the same thing as this initial value, A. So both of those are the value of the population at time 0. So n sub 0 is the same thing as 0.1483. E is a constant, and K here is that growth rate that I need to solve for. So let's write an equation to do that. So I've started a little bit of that process here. If those two initial values are equal, then we can look at just the exponential part of the model, the base raised to the exponent. These must also be equal. And then using that property of exponents, I could further say this is the base, 1.3187, and here I have a base, e raised to the k. Notice both then, that's assuming that both x equals t, and they are equal there in this model. They're both the input or independent variable. All right, so I now need to solve for k. And to do that, I can rewrite this as a logarithmic, natural log at that expression. So I'm going to find the natural log of 1.3187, and that gives me k, the growth rate. So I'll come back over here to do that natural log of 1.187, and I get this approximate value. I think I also have to round to 4 places. And piecing those two parameters together in this form of the exponential model, we get the following equation. All right, next we're asked to graph, and that one's pretty simple since we have that graph from Desmos. Maybe the only thing we could do to make it a little bit better to match is change the window settings to be the same as our answer choices. I see each of them have a y-axis from 0 to 1 and x-axis from -1 to 7. So if we come over here to these settings, we could do that same thing. And from 0 to 1. And coming back to these, you may need to increase the size to see them a little bit better, but I believe A should be the best answer choice. And then the last thing is using the model to predict at x equals 7. And of course, we could use Desmos to do that pretty quickly. So I'm going to use that first model just because I have these same values up here. And that should be the right answer choice. Which rounded to 2 decimal places is 1.03. For this last part, I'm going to get a little creative with using Desmos if I want to find when the population will reach 1.05. Let me clear out some of this here. I want to type y equals 1.05. And I do need to move my window a little bit, so I'm just clicking and dragging to move it. And I want to find this point of intersection. So here is the x value that is on that point of intersection. And rounded to 2 decimal places is 7.08.